Now, see, atom is the smallest indivisible particle in the nature, and we have fundamental particles, electrons, protons, and neutrons are known as fundamental particles, or basic building block of an element of an atom. Basic building block of an atom. Now, see, other than these, there are 105 particles, 105 particles in an atom, but they may be present or may not be present in any atom. Suppose may be present in one atom, may not be present in another atom. Okay, so here the first one is electron. So electron, the charge of electron. What is that? The charge of electron is discovered by J. Thomson. Okay, J. Thomson. And the mass of an electron was discovered. Sorry, yeah, it was so RN millimeter. Okay, so here we have the charge of electron is given by minus 1.602 into 10 to the power of minus 90 kilojoules, and mass of an electron is 9.11 into 10 to the power of minus 31 kg. And if you are comparing the size of the electron to size of the atom or size of the proton, it is size of mass of electron is 1 by 1837 times of mass of hydrogen atom. Okay, so the symbol is what? E minus 1 0. Is that clear? The symbol is E minus 1 0. Okay. Okay, so no. So here charge of the electron is J. Thomson, mass of the electron is Ra, was discovered by Ra Millikan, and this is using the a liquid drop model. They have found out this. And then charge of electron value, mass of electron value is their mass of electron, comparison with the mass of the hydrogen atom. Means if you are breaking an atom into 2000 pieces, then one piece is equal to the mass of electron. Next, we have the electron symbol E minus 1 is the charge and 0 is the mass. Next is the second part is proton. What is proton? Proton was discovered by Rutherford. Okay. Okay, proton is discovered by Rutherford. And mass of charge was charge of proton. We can say this electron, this was discovered here, and we can say charge of the electron was discovered by Rutherford, R.A. Millikan, and electron was discovered by J. Thomson. Here also proton was discovered by Rutherford, and charge of proton was discovered by Goldstein. No need to remember the names. So charge of electron is plus 1.602 into 10 to the power of minus 19 coulombs, and mass of the proton is 1.66 into 10 to the power of minus 27 kg. And here the formula is P11. One is the charge and one is the mass. Okay, next one, the last one is about the neutron. Okay, third one is neutron. So neutron was discovered by Chadwick. So charge of electron is 0, and mass of electron is how much? 1.67 into 10 to the power of minus 27 kg, and N01, that is this is 0 is the charge and 1 is the mass. Okay, is it clear, all of you? Is this clear? No.
Yes, sir.
Yeah, but next thing is about why the name is given dual nature of matter and radiation. See, there were two group of scientists. One group of scientists supported that light travels in the form of waves, and the second one they told like light travels in the form of particles. Okay, who supported that particle nature? The particle nature was supported by Newton first. Newton has supported this. Then Einstein. Okay, Einstein has supported that light travels in the form of particles. This means photons. And Max Planck also supported that light travels in the form of particles. Then wave nature. Who supported? Huygens supported the light travels in the form of waves. And Thomas Young also supported that light travels in the form of waves. Then who is right? Okay, that we'll discuss at the end of the topic. Okay, who is right, whether it is particle nature or whether it is wave nature. Okay, that we will discuss now. Clear? So copy this fast, then we'll go ahead. See, there are three ways in which electron can be emitted. One is thermionic emission. Okay, then second one is what? Field emission. Second one is field emission, and third one is photoelectric emission. Third one is photoelectric emission. Okay, thermionic emission, field emission, photoelectric emission. So the first one is thermionic emission. So what is thermionic emission? See, when you have to take a filament. Okay, like suppose a filament is heated, a high potential difference is developed across the filament. Then what happens? It will become heated up, and what happens? It starts giving the electrons. It starts giving electrons. So this is said to be thermionic emission. Is it clear? Like by suitable heating, sufficient thermal energy can be imparted to free the electron, then to come out of the metal. So when you heat the filament, when a filament is heated, electrons are ejected out. So this is said to be what? Thermionic. Okay. This is said to be thermionic emission. Second one is what? Field emission. The field emission is like suppose it is between two plates. Okay. Means like suppose like we have a tube, like a tube light. Like suppose there are two plates here. Two plates. One is positive plate. One is negative plate, and one is positive plate. So what will happen? When you apply the potential difference, and there is some gas in it. Okay. Maybe some zero group element. Maybe neon, helium, neon, argon, krypton, xenon, radon. What are they? Helium, neon, argon, krypton, xenon, radon. What are they? They are inert gas elements, right? Inert gases, right? Or eighth group element or zero group element, noble gases. Is it not? So when you fill this tube with the zero group elements, then they won't react because zero group elements are very stable elements or atoms. So what will happen when you apply potential difference across this? Then what happens? Electron starts moving from negative plate to positive plate. Okay. So this type of emission is said to be field emission. Okay. So how much it is? 10 to the power of 8 volt per meter. So how much volt you are applying? 10 to the power of 8 volt per meter. When you are applying this much volt, then what happens? Electron starts ejected out. Okay. So when a potential difference is applied, across, okay, across the plates, then electrons are ejected. Then that is known as what? Field emission. The next one is what? Photoelectric emission. Please copy this, then we'll go to the next. Is this clear, all of you? Photoelectric emission means what happens when light of certain frequency incidents here, electrons are ejected out. Okay, that is HM here. So when light of particular frequency, is incident on the metallic plate, electrons are ejected out. So this phenomena is known as photoelectric emission. Now, is that clear? I think they deleted some topics also here. Can you please check the topics what